Hello, welcome back. And today we're going to talk about finding the exact value of the trigonometric functions used in the unit circle. Remember when you were in high school studying trigonometry, the unit circle is a circle with a radius equal to 1 and whose center is equal to the origin of the rectangular coordinate system. We also remember that the circumference of any circle with a radius equal to 1 has a length of 2 pi units, which is 1 revolution around the circle. Now, let's look at some examples. We have 2 graphs on the board here. And with those graphs, we have P at a point there at AB, and we have S is equal to T units. Now, this is what I did. I drew a vertical real number line with an origin of the number line at the order pair 1, 0 in the Cartesian plane. Now let's let T be greater than or equal to 0. Be any real number, and let S be the distance from the origin to T on the real number line. Now, you see that black portion there on figure A? Now look at the unit circle in figure B. And beginning at that point, that order pair 1, 0 on the unit circle, now travel S is equal to T units in the counterclockwise direction. You see that? Along the circle to arrive at the point P, which is A equal to AB. That's a point on the unit circle there. And in a sense, the length S is equal to T units is being wrapped around this unit circle. You see what I'm saying? And if T is less than 0, we begin at the point 1, 0, and the unit circle and travel S is equal to the absolute value T units in the what? What motion? A clockwise direction to arrive at the point P, which is equal to AB. Now look at figure B there. Now if T was greater than 2 pi, or if T was less than negative 2 pi, it would be necessary to travel around the unit circle more than once before arriving at P. Now, understand something here. It's almost as if you're taking a piece of string and you're wrapping it around the unit circle. But wherever that string stops, that's where the point P is, which is A, B. Now, let's look at the definition here. Let T be a real number and let P equal to AB, which is a point on the unit circle that corresponds to T. Sine function associated with T, the y coordinate of P is denoted by sine T is equal to B. You see this? And cosine function associated with T, the x coordinate of P, is denoted by cosine T is equal to what? A. Now, if A cannot equal to 0, the tangent function associated with T, the ratio of the y coordinate to the x coordinate of P, is denoted by tangent T, which is equal to B over A. Now, if B can't equal to A, then the cosecant function is defined as what? Cosecant T is equal to 1 over B. What does that remind you of? It reminds you of those reciprocal identities again, doesn't it? If A is not equal to 0, the secant function is defined as secant T is equal to 1 over A. Now, look at here. If B is not equal to 0, the cotangent function is defined as cotangent T is equal to what? A over B. Now, since the unit circle is used in these definitions of trigonometry, these are also referred as circular function. Let us remember that cosine T and sine T corresponds to the point P on the graph there. P is equal to AB, which corresponds to the XY coordinate along the unit circle. In other words, now T is used to approximate a point on the unit circle. Now, let's do a problem. And if you will, follow me over to our other board here. And if you look, you notice that using a point on the unit circle, this is what we're trying to do today. However, the problem itself, it said find the value of sine t, cosine t, tangent t, cosecant t, and secant t, and cotangent t, right? If P is a point on -1/2, and also square root of what? 3/2 is the point on the unit circle that corresponds to the what? Real number, what we said earlier, t, right? However, let's get into the problem. Our solution, what we want to do is always write what's given here. And P is equal again to -1/2. And of course, B is going to be the square root of 3/2. And this is represented as the ordered pair here. And of course, we said A is equal to -1/2 and B is equal to the square root of 3/2. Now, we always got to use a formula of the Pythagorean theorem. In this case, R squared is equal to what? A squared plus B squared, to find alongside of this, or actually find the true radius, right? From that point of the circle, right? And here we have -1/2, that is, squared plus square root of 3/2 squared. And then of course 1/4 plus 3/4 is equal to 4/4, which is going to be equal to 1. So now we got everything that we need to start to calculate our trigonometric functions and our values. So sine t is equal to b. In this case, we're going to say sine t is equal to the square root of 3/2. Well, actually, sine t is what? Is b right here. So all this is the square root of 3/2. That's it. No real major calculation there. It's just that b is represented by that, sine t. Cosine t is equal to a. So that a value here is going to be what? -1/2. And then we go here to tangent t is equal to b over a. Of course, we have some work to do. That's going to be square root of 3/2 divided by -1/2. And this is going to equal to the square root of 3/2 divided by -1/2. And that's going to equal to the square root of 3/2 times, of course, you take the reciprocal when dividing fractions, times -2/1. So your solution, your answer is going to be the negative square root of 3 is your solution for that. So now we go cosecant t and secant t and also cotangent t. And here we have cosecant t and secant t as the reciprocal identities, right? So we actually plug in the values for b and we do our calculations and we end up having this answer 2 times the square root of 3/3. And for secant t, of course, 1/a, we plug in the value for a, which is -1/2. So that's going to be -2. And then cotangent t is going to be what? The square root of 3/3. Now again, cotangent t, what you're going to do here, this is going to be a divided by b, and this is going to be -1/2 divided by the square root of 3/2. You're dividing fractions. And then you have to, after you get your solution, you want to rationalize the denominator, and we come up with the answer to be negative square root of 3/3. Now, of course, what you might want to do is always do what? Always stop the tape or stop the video and copy the notes and save your questions for class, and make sure you can get an understanding and be responsible of your math. Make sure you be careful in calculating any of your arithmetic so you won't make any mistakes or small errors. Always go back and check your work over. Now, let's talk about trigonometric functions of angles. Now, let B, AB, be a point on the unit circle corresponding to the real number t. Look at figure A. And let theta be an angle in standard position measured in radians, whose terminal side is a ray from the origin through P, and whose length is, this is going to be the absolute value of t. Look at figure B right here. And since the unit circle has a radius of 1 unit, and if S is equal to the absolute value of t units, then from the arc length formula is, remember this, is S is equal to R times the absolute value of theta. So we have theta equal to t, what, radians. So C, look at the figures C and D right here. Look at it very, very closely. And the point P on the unit circle that corresponds to the real number t is also the point P on the terminal side of the angle theta, which is equal to t radians. Now, look at the setup right here. Notice this setup. This setup right here shows you that sine t, which is a real number, is equal to sine theta. And theta is in t units. We will stop this video for right now, and we will pick up on the next video of trigonometric functions of angles concerning and dealing with the unit circle.